Okay, so I'll do a bit of a demo for the practical test. So this is actually an old one from previous years, this practical. So basically we've got this network over here. So we've got 3 internal routers named R1, R2 and R3. We've got an ISP router, and so we basically need to configure the link between R1 and the ISP. No routing protocol running over that, of course, so you need default routes in both directions. So we've got this core network that EIGRP is going to run across, which is the protocol we're using in this lab. So we've got a LAN from this branch office. We've got a LAN for the main office, and so they've also got the core network is 192.168.10.0, branch office is 12.0, and the main office is 13.0. And so we'll just go over to the left here and have a look at the requirements for it. So basically, we need to configure EIGRP as the routing protocol using autonomous system number of 14. You need to configure EIGRP to advertise the core and main office and branch office LAN networks. Do not run EIGRP between the ISP router and your network. So you need to use, as I said, default routes for that. The main office and branch office LAN router interfaces need to be set passive. But of course that's just for that interface here, not both, because of course if you make this one passive, it's not going to talk to the rest of the network. And so now I'll have to swap that. For some reason I wired it wrong. And so basically G00 on all of these routers point at the core network, and so we're going to passive interface G01 on them all, basically. So that'll work. What else do we need to do? You need to address the routers connected to switch 2, which is all of the routers. Oh, switch 2 is the core one, of course. And so they all belong to 192.168.10.0. The address to use on router 2's connection to switch 4, which is this one, is 192.168.12.0. Its connection to switch 3, is 192.168.13.0. Then you need to do default routes between R1 and the ISP, and in both directions basically. All the routers need to have a router ID. You need to advertise that default route using EIGRP, and we need to configure ether channel on these switches here. And so it's going to require 3 separate ether channels. You can't put them all in the one ether channel, that will not work. And you need to configure the IP addressing for the hosts, so this PC and this PC. Now, this is a test, and so there were merit activities as well. And so basically we'd like you to change the hello time to 2 seconds instead of the default 5. And we're going to create the root bridge for spanning tree to be switch 0 instead of the one that it's fallen to at the moment. So, all right, let's have a look. So I've actually got a pre-prepared config here. And so I don't think there's any addressing done on any of these. No, there's not. So we've got to configure them from scratch. And so I'm just going to address G00. Of course, that's on the 10 network. Now this one's got, I think it's that interface actually, from memory. Let's have a look. Yeah, 010. We've got to set the IP address to that. It's from the 99 network. It did actually mention it there somewhere. I might have skipped over it. Yeah, here it is. WAN link address R1 ISP 99000/30. And so the first address goes on the ISP, the last address goes on R1. So, of course, with the /30, you've only got two valid host addresses, 1 and 2. And so this is R1 I'm going to configure at the moment. So it's .2. R1 doesn't have a G01. So router EIGRP 14 for the AS number, passive interface G01. It's got a router ID of all the ones because it's router 1. And we need a network command for 192.168.10.0. This is on R1, so it doesn't have any LANs attached other than the core LAN. And so we want it to redistribute static. And then, of course, we need a default route as well. And so let's get this router 1 up. Okay, so that all that's been configured is the host names. So this should work nicely. Now, the configuration I've thrown in, IP address for G00, serial, these are all commented out so they didn't happen. Then router EIGRP, passive interface, so one network command, redistribute static, then there's an IP route command, and that's it. So let's do show IP route. And at the moment it's just going to be the directly connected network, the LAN. The WAN didn't come up because the other end hasn't been configured yet. So let's copy this. So we're into global config mode. Now we need to change the interface to 000, IP address to 1. Copy, paste, and we need a static route. That should be it. Show run, and so it's got the interface up. It's got the default route, show IP route. It's got the gateway of last resort, and it's got the WAN, directly connected WAN link. Let's see if it does work. So we can just ping the LAN interface on the other router, 192.168.10.1, and it works. And so the default route's working, and of course the return default route worked as well. So that seems like good for 2 routers so far. Now for router 2, of course, we need to have the LAN 12 involved. So we need to get rid of the comments for G01. We need to put in the correct router ID. We need to have a network number for network entry for 12. We don't need a default route. Oops, wrong key. And we don't need to redistribute static. All right, so let's see how this goes. Whoops. Router 2 will have .2 on there. You can't have the same address as the other one, can we? So get that going. Paste. Now, the interface, so that's all Sorry, I didn't comment out the serial interface. Doesn't matter. G01. So we have an adjacency with the other router, so that's a good thing. Show IP route. Bigger text makes it very ugly. Anyway, so we have the directly connected 10 network, we have the directly connected 12 network, and we've learnt the default route from the other router, so that's a good thing. That's the only thing we had to learn from the other router. Now I'll comment out the serial interface. We don't need that interface again. Didn't need it last time, actually. Now, we've got to do router 3. And so, of course, we'll make it .3 for the 10 network. It used to be on the 13 network for the LAN. We need the correct router ID. We need the correct network number in the network command. So 13 is the one we need. We don't need all the default routes. So copy. Paste. Any errors? Don't see any. Now we should hopefully get some adjacency messages. If I've got it right. Show IP route at the moment. It's probably not going to tell us a great deal. Well, there we go. Now we've got adjacency. Let's try that again. And so it's learnt its gateway of last resort. It's also learnt network 12 from router 2. And of course it's directly connected to network 10 and network 13. So that looks pretty good. So if we do a show run, we can see what's in there. So it's router 3. It's got 10.3 as its core LAN interface. It's got 13.1 as its the main office LAN interface. It's got a router ID of quadruple 3. G01 is passive interface, and the 2 network commands. And that's about it. So that's pretty good. So if we want to check through our list here, AS14, yes, we've got that. EIGRP is correct. Main office and branch office LAN interfaces are passive. I've done that. We've got the three Ethernet networks configured, and they're exchanging routes. We've got the WAN link, and that's working. R1 to ISP, ISP to R1. I've done that static route there. Haven't done Ether channel yet. We can have a look at that later. Address the host. So now that we've got layer 3 working, let's address the hosts and see if that works. Might as well not get too far ahead of ourselves. 192.168.13.10 will work. 192.168.13.1 is the router. That should be enough. And so on this host, it's on the 12 network, 192.168.12.10. 192.168.12.1 is the router. That should be enough of that. All right, so let's go ipconfig information looks right. Let's ping our own router. 192.168.12.1 is our router. That works nicely. Let's ping the other host, 13.10. Might lose a packet or two for ART requests, but it should work, and it does work. And so let's ping the ISP. Ping 99.0.0.1, and that works as well. So layer 3 is exactly how it needs to be. So that looks like it's pretty good. Suppose we could try this host, pinging the 99, just to that it works, and it does work. So that's all a very happy little situation. So the only thing I haven't done is the ether channel. So of course that's these three here. So we've got 9 links total, 3 switches, and so 3 links here. And so of them, only 2 of them are active. The top one there and the bottom one here, and all the rest are inactive. So 2 out of 9 is not a very good rate. So of course that's spanning tree that's doing that. And so if we combine them together into ether channel, each one of these group of 3s will be deemed to be a separate link. And so that certainly is a desirable situation. And so I've got the config here for it. And so because there's 3 separate bundles or ether channel groups, you actually have to create 3 ether channel groups. And actually what I might do, I might actually, I probably should fix this file. I'll put it into port 10. That's not one of the ones we're using. I'm going to do, I've got an interface range here for fast Ethernet 1 through to 3. So that's 1, 2, and 3. They're going to be a member of channel group 1. And then we've got interface fast Ethernet 19 through to 21. That's why I use 10 for this one. It's going to be part of channel group 2. And here, 22, 23, and 24 are going to be members of channel group 3. And so the reason I've done it like this is I only really need to define 2 channel groups per switch because that's all we're using. But hey, I'm just trying to speed up the process here. And so that's the configuration we're going to use. And so of course this will create the interface channel 1, 2, and 3 in there. So let's go paste. So this is switch 3. Now, of course, we've changed things greatly, and so as you can see, there were some red lights that came up. But anyway, let's do a show run. We'll have a look. So as I said, there's the interface port channel 1, 2, and 3. And so of course, within that, that's when you might configure it to be a trunk link or something. Of course, we don't have multiple VLANs here, so there's no need for that. And so as you can see, for ports 1, 2, and 3, they've now got that channel group 1 mode on. And so away we roll. And then if we look at the last 6 interfaces, 19 through to 24, the first 3 are part of channel group 2 and the last 3 are part of channel group 3. And so as you can see here, it has changed a little bit. We've configured switch 3 and you can see that all 3 of these are done. And so this is actually dynamically turned it on this end and that end. And so I could actually not do anything else and that would just stay as it is and work nicely. But I'm also a bit of a control freak, so I like to configure these things myself. And so if we paste that same config in again, going to break things for a little while. Let's do a show run. And so again, we've got those 3 port channel interfaces that have been created. And so 1, 2, and 3 are in channel group 1. (19) through to 21 are in channel group 2. And 22 through to 24 are members of channel group 3. And so again, you can see that we've got some links that are up. So let's do the same here. Paste in, show run. And so we've got the 3 channel interfaces configured. First 3 interfaces are in group channel 1. 19 through to 21 are in group channel 2. And 22 through to 24 are in group channel 3. So maybe fast forward a bit of time for spanning tree to get over it. And now we have all 3 of those links and all 3 of these links active. All 3 of these ones are in standby. Well, we've got 6 out of 9 now, so a 66% rating, and so that's certainly a lot better. And so we got 300 megabits in each direction instead of 100. So that's certainly an improvement. So let's try that ping again on here. See if it still works. Works like a champion. So that's basically the pass section finished for that practical test now. So basically all we've got left now is the merit section, and so there's configure EIGRP in all 3 routers to use the hello time of 2 seconds for faster convergence, and then configure switch 0 to become the root bridge. Now I might actually do the STP first. Now if we look at switch 0 and we do show spanning tree, so you'll see that this is the root ID, this is switch 0's ID, and so they're different. And so switch 0 is currently not the root bridge. So I think from memory it normally ends up being the switch 3. But anyway, so we've got the configuration here. So conft spanning tree VLAN 1 root primary. And so of course that means this is the switch I want to be the root most of the time. Paste it in. Don't see any errors. Now, let's fast forward time because spanning tree is now calculating. And you'll notice that instead of this link being in standby, it's now this link in standby because this is now the root. Well, that's what I'm assuming has happened. We'll have a look shortly. And so, of course, this is the center of the universe as far as layer 2 switching is concerned. And so that's why it's changed as opposed to this one. So let's have a look. And so let's do show spanning tree again. And so as you can see, it now says this bridge is root. And so it's changed it. And so as you can see, the priority is now 24577. When we looked at it previously, it was 32769. And so that's why it is now the root, because the value has been decreased, and the lower the value, the more chance it'll be root. So if we do show run, you'll actually see what went into the configuration, and it's this command. So even though I put in root primary, the switch itself calculated this value. And so the priority value of that, and then of course, I think if we look at, it's actually 577, that's because it's that plus the 1 from VLAN 1, the VLAN ID. And so that's why it's 577 instead of 576. So that's how it calculates it, of course. And so now we have switch 0 being the root bridge. Now the other one, is to get EIGRP with a hello time of 2. Now by default, EIGRP has a hello time of 5, and so we need to do this configuration stuff here. So you do it on a per interface basis. So of course the only interfaces that are talking on this LAN, which is where the interfaces are exchanging, are the G00s, and so that's where we need to do the configuration. So IP hello interval EIGRP 14, 2 seconds. And so that's all you need to do. Now, if you remember last week when I did the demo for the OSPF, as soon as you did it, it actually broke adjacency. But if you also remember a few weeks ago when we looked at EIGRP, EIGRP doesn't actually compare those values. And so that is enough of that, and that should actually have it all done now. So if we do a show run, you'll notice that on G00 we've got an IP hello interval for EIGRP 14 of 2 seconds. And so that's basically how you do that. Okay, so show IP EIGRP. Interfaces. So it tells you we've got so it's EIGRP 14 on gig 00. We've got 2 peers, and so yeah, not a lot else. Okay, so that's pretty much it for the demo. So of course next week we'll be doing both tests, and so at 1:30 we'll start the theory test, which is of course online from the Cisco site, and then at 2:30 we'll start the practical test. And so everyone will get, again, what I normally do, I'll get you a mail merge, and everyone will get unique numbers for the test. All right, so that's it for the demo for today. Have a nice day. See you and weekend, and I'll see you next week. And yeah, good luck with the test next week. Have a good one.